Today we are going to discuss about pH. Now this means P stands here for potence, hydrogen ion concentration. That means, and potence means student power. So it means the power of the hydrogen ion concentration. So this pH is the negative logarithm of hydronium ion concentration. Similarly, student, we can write down the pOH also. That will be minus logarithm hydroxyl ion concentration. Right? So if you know the hydronium ion concentration, so you can put it over here and you can find out the pH. In the same way, by knowing the hydroxyl ion concentration, you can find out the pOH. But student, if only hydrogen ion concentration is given to us, then also we can find out the hydroxyl ion concentration. Now, just see here that we have H3O positive hydroxyl ion concentration equals to kW. Now, take log on both sides, so it will be log H3O positive plus log hydroxyl ion concentration is equal to log kW. Now, log hydronium ion concentration, student, just get this minus over here. You will get minus pH plus here it will become minus pOH equals to log kW value, student, how much? 10 raised to power minus 14. Right? So we have here minus pH minus pOH equals to, so what is log 10 raised to power minus 14? It will become minus 14 log 10. So it is coming minus 14. So minus pH minus pOH equals to minus 14, or we can write down pH pOH equals to 14. Right, students? So if we know the pH, we can students find out the pOH value easily. And you all know that when pH is equal to 7, it is a neutral solution, and pH greater than 7 alkaline, and if pH is less than 7, student, it is a acidic solution, right? So pH, if it is having lower solution is having lower pH, student, it will be a acidic solution. If it is equal to 7, it will be a neutral solution, and if it is greater than 7, student, it will be a basic or the alkaline solution, right? Student, here we are going to discuss the relation between Ka and Kb. Now, what is Ka? It is the acid ionization constant, and what is Kb? It is a base ionization constant. So let's take first the reaction for the acid ionization constant, that is Ha. It's an acid. When it is being dissolved in water, it will give A negative, its conjugate base, and hydronium ion. From here, student, we can write down from law of chemical equilibrium, we can write down the equilibrium constant. So it will be A negative, this is H3O positive upon HA water. Since water is in its pure state, so it is a constant. So the expression can now be written as HA. So here K into H2O will become Ka, that is acid ionization constant, which will will be equal to A negative H3O positive upon HA. This we will make it to be equation 1. Right? Now, next we are going to write the expression for the conjugate base, that is A negative here, right? With respect to water, here it is acting as a proton acceptor, so it is forming Ha plus giving OH negative ion. So here we will write down from law of chemical equilibrium the equilibrium constant, which will be Ha OH negative upon A negative, and this is water. Again the same step, K into H2O will give Ha OH negative, and this is A negative. So K into H2O here will become constant, it's Kb, that is base ionization constant, and we will get here Ha OH negative, and this is A negative. This is equation number 2. Right? Just get these two equations multiplied. So multiplying equation 1 and 2. So I will be multiplying here. So it is Ka into Kb, that is LHS with LHS and RHS with RHS, A negative, H3O positive, this is Ha multiplied by Ha OH negative, and this is A negative. Right? Get the thing cancelled. So we can write down the next equation here. So you can see this Ha will get cancelled with Ha, A negative with A negative, and we will have an H3O positive and OH negative. Right? And if you remember, what is product of hydronium and hydroxyl ion called? It is ionic product of water. So since Kw equals to ionic product of water, therefore Ka into Kb will be equal to Kw. That is the relation between the acid ionization constant and the base ionization constant, student, is ionic product of water, that is Kw.